Good morning, everyone. I'd like to welcome you to this very important day for us in the School of Computer Science and for Carnegie Mellon overall to announce this major new partnership that we're forming with Yahoo Research. Yahoo's been a strong supporter of Carnegie Mellon for many years. Just thinking of a few things, they provided access to a major computing facility called M45 for us, starting in about 2008, that let us start doing research on how do you work with very large collections of data and do the computing over that large data. And that access was instrumental, actually, for a number of projects, including a lot of the core work that's going to be the basis of this future work we're describing. They've also given machines for us to use as server facilities, both in SCS and in the Heinz School, to do data analysis of different types. They've been very generous with funding of graduate fellowships. We have a ping pong table, it's purple. And overall funding many student activities, and we're very grateful for that. But today what we're talking about is a much bigger step, both in terms of a dollar amount, but also in many ways more significantly in terms of what kind of connection we're forming with Yahoo and what kind of partnership we're forming. And that's what we're really going to talk about today. But, I'd like to now introduce President of Carnegie Mellon, Subra Suresh, to give some remarks on his perspective on this as well.
Thank you, Randy. Welcome, and thank you all for coming this morning. It's my pleasure to let you know, most of you know already, that Yahoo is committing $10 million to a joint research project with CMU faculty and students in the School of Computer Science in the departments of machine learning and human-computer interactions. So this funding will support an exciting new research project, which our colleagues have called Project InMind, which will be the next generation of a personal agent that will guide us in our day-to-day lives through a variety of devices, portable devices, in discovery, learning, and navigating through our day-to-day lives. This is an unprecedented level of support for Yahoo for a research project of this kind. And we are really delighted that Yahoo has chosen Carnegie Mellon as a partner to make this happen. And I can say that this can only happen with a company that's as innovative as Yahoo in its outreach to the scientific community, and to a university as broad and as deep and as innovative as Carnegie Mellon. So it's really a perfect match. Top scientists, faculty, students from CMU, top scientists and engineers from Yahoo Labs are embarking on a mission, a unique partnership involving major investments of time, money, real-time data, intellectual resources, and two-way intellectual traffic between Pittsburgh and Silicon Valley. And we know in the wintertime which way it's going to go, but at other times it may go in a different direction. And if you see some of our faculty and students and some of our Yahoo colleagues running around campus with strange devices and strange behavior, you know why that's happening in the future. I had the pleasure of talking to Yahoo CEO Marissa Mayer just a few weeks ago at the World Economic Forum in Davos. And in the brief conversation that she and I had, it was abundantly clear to me how excited she was about this project. And I also had the opportunity to meet with several members of the senior leadership team at Yahoo. I can also say a few other things from the different vantage points from which I've looked at these kinds of interactions. Earlier in the press release, Tom Mitchell pointed out that when you go to a typical funding source for a faculty member or a student, you go to a federal agency to get support, such as the National Science Foundation. Typically, it's a finite amount of money for 1 or 2 students in a typical project, unless it's a major center, for a relatively short period of time, 3 years, and that provides you an opportunity to do scientific research in a certain way, but may not give you the bandwidth, either in terms of resources or in terms of opportunities to explore real-time data in a major way. And one of the remarkable things about this, from my previous vantage point as the director of the National Science Foundation, is that embedded in all of this is deep, rigorous, highly scholarly scientific and engineering research. And that research, combined with industrial relevance, industrial applications, and human behavior, can change global society in unprecedented ways. And that's what this partnership is all about. So Yahoo is a cool company, and we may have cool portable devices at our disposal. That's fine. Underlying all of this is scholarship. Let's not forget that. And this is a very, very good example of how intellectually powered, deep, rigorous, scholarly work changes the world. The last thing I want to say is that the combination of skill and imagination that exists at the School of Computer Science and across Carnegie Mellon will be a foundation for superb partnership in this discovery and this journey over the next few years. Personally, I'm really looking forward to seeing what exciting science, engineering, products, and lifestyles will emerge out of this partnership. And I'm really proud of all my colleagues and students at CMU. I'm also extremely grateful to our friends and partners in this, colleagues from Yahoo. I would like to also thank Ron Brockman, Chief of Yahoo Labs, and Don McKillen, one of our own alums, who's involved in corporate relations at Yahoo, for all their hard work, and also Beverly for her efforts, and many of the colleagues from Yahoo who have joined us this morning. Thank you very much.
Good morning. I'm Ron Brockman from Yahoo. It's a great pleasure to be here today. Thank you, President Suresh. Thank you, Randy. I loved what you just said, because not everyone knows it, but the idea of rigorous scholarship, sort of deep scientific thinking applied to very pragmatic and important problems that people care about is really what Yahoo Labs is about. And so that makes this partnership just absolutely ideal. So what I wanted to do this morning is very briefly, and it will have to be brief, give you a quick overview of Yahoo Labs for those of you who are not familiar with us. I guess I'll have to go back and forth here. Apologies. It's kind of interesting. Many of you are familiar with Yahoo. Many of you use our services. But quite a few years ago, when the idea of bringing a research capability into a very young internet company was raised, at first there was a lot of skepticism. The pace at which innovation happened in the company was extremely fast. Not necessarily a lot of rigor went into experimentation and deployment of services and products. And when you look at sort of equations like you see in front of you, people would scratch their head and say, how could that possibly be relevant? But a lot of things have changed over the last 10 years or so. And now I think the view is shared across the entire senior management of the company and probably throughout the entire company that research of the sort that you all do and are intimately familiar with is absolutely fundamental to the success and certainly the future of the company. And with that, a number of years ago, we started to build up a research capability, focusing on the areas which made the most sense for the company at the time. And those capabilities have expanded over time. and as did our outreach to universities that allowed us to eventually conceive of and start to execute projects like this. The labs itself has more than 200 people now worldwide. I'll show you a quick map in a moment of where we are. We hire mainly what we call scientists, which are always PhD level graduates in many different fields, which we'll talk about in a moment. And we have also a very strong class of engineers that work in an experimental mode that we happen to call research engineers. We do, in some cases, very fundamental exploration of computational and economic phenomena. Computational is obvious, but when you do things like deal with very large numbers of advertisers, large numbers of places advertisements can appear, and many, 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 many customers using your services, the combinatorics and the notion of markets come into play very significantly. From the original sort of simple-minded view of auctions for keywords on search pages to a wide variety of bidding mechanisms for complex campaigns, economics is the heart of a lot of what we do, certainly in our advertising business. Another thing that we do, typical role for a corporate research lab, is we try to anticipate technology changes, scientific developments that are created in the world around us, and look for opportunities for the company, even if we don't invent them ourselves. So one of the reasons it's wonderful to have very strong relationships with the academic community and to participate in international conferences and publications is that you get to share both ways, both what you're doing and what other people are doing. And that's very critical. Silicon Valley thinks very highly of itself in many ways, and a lot of it's sort of an inward-looking, self-sustaining ecosystem. But the fact of the matter is, we all know not everything of merit is invented in California. So it's very important that we keep our eyes and ears open and work very closely with the very innovative people who exist everywhere outside of, not only in California, but elsewhere. The other thing that we care about, because we're a very large consumer-facing company, as you know, if you include the Tumblr acquisition, we have over 1 billion customers. It's a pretty large number. I don't know the total amount of data that we have, but it's large. It's certainly in the petabytes, multiple petabytes range. But what makes or breaks companies like ours and what can help people best is sort of very largely determined by societal processes. And so we very much need to understand both how individual users interact with technology, and therefore there's great interest in the Human-Computer Interaction Institute here as well as larger demographic things that happen. And we've now all seen the rise of computational social media, and they seem to have a very profound effect on the way people consume services and communicate with one another and share information. So again, we can't just sit in our offices and invent stuff. We need to understand what's going on in the world at large. So we play multiple roles in our labs on behalf of the entire company and our customers. Now, with respect to the kind of work we do, sometimes people think that industrial labs tend to be totally applied, very near-term focused, and barely doing what we would all think of as science. And we certainly do some of that. That's of necessity because of some urgent needs to get innovative things deployed. But we really cover the full spectrum of work from basic research to very applied work. I like to think in terms of the term that came from Donald Stokes' book called Pasteur's Quadrant. I don't know if you're familiar with it, where there are different types of basic research, and it seems most appropriate in an industrial setting to do something you might call use-inspired basic research. Very fundamental. You have no prediction on whether your experimentation will succeed. You're dealing with very challenging computational, mathematical, and physical phenomena. But nevertheless, you always have in the back of your mind what the world would look like if you succeeded and how it might change things in people's lives. So you kind of use potential use as an inspiration for the focus of your work. Although, of course, we can never predict how ultimately our technology will affect the world. But in any case, we do fundamental research. We do a lot of publishing. We're very proud of our Best Paper Awards and Fellow Awards and chairmanships of various conferences and organizations. In that regard, if you visited us, you'll see we feel in many respects like a university setting. But we also have very, very significant connections to our software development teams. We call them engineering at Yahoo, and our product folks, so that we can help them succeed, and also really interesting ideas that we come up with actually make their way into products, and in some cases very, very rapidly. And I'm happy later to talk about examples of that. The mission, I've just sort of implied the mission overall of the organization. Basically, we are the forward-looking thinkers in the company. We provide deep technical expertise in a wider range of critical subjects to product and engineering folks and corporate management and strategy. We try to be the incubator for pretty significant scientific experimentation that will ultimately lead towards more inspiring and more delightful products for our users to take advantage of. The Labs was established in 2005. We started out as a core research organization. We eventually expanded to include more of what we call applied science. And I have to say, like many organizations, we've had our ups and downs, you know, the economic sort of structure that surrounds us. But nevertheless, we have had undeniably critically and incredibly strong support from our corporate management from the very day we established the organization in 2005. It's been kind of staggering. I've worked in other places like AT&T and the federal government. We don't have go, no-go conditions. We don't have to write proposals to do our work each year. And by the way, in case any of you are wondering, nor do you in collaborating with us. No go, no-go conditions. And in fact, we have a very simple funding mechanism, which is direct funding support from the very top. And for any of you who have lived in other corporate worlds with different models, that's an incredible place to get started. So we have been thrilled with that level of support continuously. You're all familiar with our relatively new CEO. Marissa Meyer actually often identifies herself as an AI person. She's happy to get down in the trenches and talk machine learning math with you, which is absolutely fantastic for us. And she's a very, very strong supporter. And this collaboration certainly would not have been possible without her direct support. I mentioned we have more than 200 scientists. I won't go over the disciplines that we have that we're working on, but they're basically the things that are obvious and in some cases a little subtle that really matter to a company with the kind of products and audience that we have. We are in a number of places around the world. Our largest location is in Sunnyvale, which is corporate headquarters. We also have a few people in Southern California. We have a growing team in New York. That happens to be where my office is, and maybe a little bit easier for you all to get to than Sunnyvale, but not more attractive in the winter, I can tell you that. We have a small location that's working in concert with the university in Chile, in Santiago. A very small but growing group in London. Yahoo has a growing presence there. A fairly sizable research lab in Barcelona, which I would highly recommend that all of you visit, especially if you like to eat. Great place. It's a great place for innovation. The city there is really driving mobile services. The International Mobile Congress is there every year. It's a great place to bring together people from all over Europe to do really exciting research. We also have a very strong and growing team in Haifa in Israel. Absolutely superb computer scientists there, many of them with a very entrepreneurial bent. We have a group in Bangalore, which is another very large Yahoo location, and we also have a team in Beijing in China. Now, the groups we have in these various places are outlined here. Again, I won't go over them. We try to avoid duplication between locations. There are some cases where you need expertise in the same field in multiple places, and we certainly try to be opportunistic, so we didn't pick a set of topics in advance and say X will be done in Barcelona and Y in Haifa and build to that. We looked for the talent that was available and collaboration opportunities within the business that were local, and there was sort of an organic growth. But we keep an eye on it, and we manage it all very centrally. We have a small senior leadership team of the labs. 200 people is a nice number. It will get bigger, but it's not too large to manage. So we are all very closely in touch, and We have multiple meetings in California every year where almost everybody comes together. So it really feels like a very, very tight-knit scientific family worldwide. We put together a quick word cloud of the words that were mentioned when people described all of the names and subject matter of the team efforts amongst our labs teams. You can take a quick glance at it. I don't think this was cooked, Tom. I don't know. But machine learning and data mining certainly stand out very prominently. I think that's real, actually. There's a very, very large emphasis in the company now in machine learning. And you can see lots of other subjects that are, again, we all know and love them and are extremely good matches to Carnegie Mellon. Now, I don't want to spend a lot of time going over detail because I'd like to have Tom and Justine come up and talk to you much more about what we're going to be doing together. So let me just run through a few areas really quickly. A lot more words on the slides than I will say. Forgive me for that. But just to give you a hint of some of the really key focus areas in the labs we have for this year, this is not an exclusive list. So if you don't see your favorite subject up here, it doesn't mean we don't care about it, but these are amongst the most prominent ones. Now, with our current very large set of consumer-facing services and the needs of our advertisers, we like to think of ourselves as primarily now what you might call a personalization company. I think the secret to success in the space that we're in the future is not just harnessing information and news and sports and celebrities and fantasy sports and things, which are very important, but getting them to people in a way that they really personally each appreciate, and all of us is different. So doing personalization at the scale of hundreds of millions of users, that's machine learning at scale if I've ever seen it. And we look at that both in the content world and in advertising. And if you look at the Yahoo homepage or many of our other key sites like Yahoo News, Sports, Finance, etc., there are already personalized streams of content facing you that could be very different for you than the person sitting next to you. The bottom of the page, you can scroll and scroll and scroll, and those articles are ranked by what we believe will be the relevance and interest to you. And we're always looking for ways for you to confirm or deny that so we can be learning constantly. So real-time learning at absolutely massive scale is first and foremost on our radar, so to speak, as a personalization company. And there are lots of other examples. If you're familiar with Yahoo Answers, there are ways of getting high-quality answers to answer questions for you, referrals from queries that involve a certain amount of learning. We've got some time series anomaly detection that we use in determining what stocks might be trending for our finance pages. We're working on some really innovative ways to use social information, among other things, in recommending photos on our Flickr community service, which has, I don't know how many photos we have. It's billions and billions, right? 9 billion photos. That's a lot for you to sort of thumb through if you're looking for something interesting. So you're going to depend on lots of machine help. And we've got some really innovative things that are in the pipeline there. You may have heard, if you've listened to any of Marissa Meyer's speeches, that mobile is really top of the list for us as a company. And we're attacking that in the labs in multiple ways. We're looking at platforms, sort of distributed computing, alerting platforms that are going to be significant because people move from one device to another many, many times during the day. We're also trying to anticipate brand new form factors for mobile computing and mobile services. And that's another place where we're really looking forward to working with you. We may not, in fact, build any hardware ourselves, but we need to take a pretty good guess at what's coming. So when it arrives, we're right there ready with personalized, adapted services that fit ideally in the environment in which these new mobile technologies are being used. We do, I mentioned earlier, we do basic research. We have a pretty significant growing effort, largely in New York, but not only in core computer science. We're hiring optimization people, algorithms people, people who really know computational complexity very deeply, people who are infinitely better at proving theorems than I am. And we are partnering them up with lots of applied people and including our engineering folks, because some of the challenges that we have given the scale of data and the stuff that we have to move around and the networking constraints and the like just needs very, very deep computational insights to address. We also have advertising as a critical ingredient of the company. That's how we, in fact, make most of our money. And there's lots of elements to what you might call advertising science or computational advertising. I mentioned markets before. Matching users and ads is pretty critical. Timeliness, running campaigns, effectiveness of ads, fighting ad spam on behalf of our users, really quite critical. And I mentioned the infinite stream. Now we're offering ads integrated in that stream, and they better be things that you like, and they better be relevant, and they better fit, or people are going to stop reading our content. So it's a very, very important element there. We're doing a lot of interesting work in video, and I just mentioned Flickr, so image processing is incredibly important to us. Don't have time to go into details, but we can talk offline. There's lots and lots of work we need to do in all aspects of dealing with different multimedia content. And I mentioned this before, let me add one more time. One of our groups in New York is actually called Scalable Machine Learning Research. And one more time, let me emphasize, we really mean scalable. And we're actually working on a platform so that engineers who have absolutely no background in machine learning, they've never heard of Bayes or decision trees, can actually easily hook up their data sources and run appropriate machine learning algorithms on them at humongous scale and get results that they can use in their work on an everyday basis. So this is a really interesting research experiment, even though it's kind of an engineering project, because we want to integrate absolutely state-of-the-art and newly evolving learning methods in a way, though, that novices can use every day, because as I've mentioned a couple of times, learning is used almost everywhere in the company. You name a capability, either internal or product-based, and machine learning probably has something to do with it. So to wrap up, you're probably aware that we have many different ways in which we reach out and connect with the academic world. We have a program called WebScope that's been around for a long time where we share anonymized data sets. There's probably close to 50 of those available now. Many of them have been used here at Carnegie Mellon. We have a program where we do collaborative work with faculty called the Faculty Research and Engagement Program. Randy mentioned earlier today about a server donation we made here. We have these incredibly large data centers, as you can imagine, and the equipment rotates pretty quickly. And so we end up with these almost brand new, not quite large numbers of servers that at one point Don McGillen sort of noticed were not going anywhere useful. And so we created this program where we could actually turn those into gifts to universities so that people could put them together. They could experiment with cluster computing, with clouds, or just use them as sort of raw scientific computing resources. Randy, I think you said there were over 400. 432 shipped to Carnegie Mellon, but we've shipped 2,000, almost 3,000 servers to how many universities? Approaching 40 different universities around the world. And that was a really wonderful insight that Don had, and now we continue to spread those around. And of course, we have a very, very active summer internship program, bringing people to all of our labs locations for what we hope to be a great summer experience. You can watch us on these various media channels. And with that, I think, Tom, are you next? Or Scott? Okay, I'm going to introduce Scott Gaffney, who's one of the senior leaders of the labs. Scott is our most critical partner with other parts of the business around personalization, and he'll spend a little time telling you about what that means in the Yahoo context. So thank you very much.
Excellent. Thank you, Ron, and thanks for giving me this opportunity. So what I try to do is get a flavor of what personalization at Yahoo is. It's very hard to do. There's a lot of depth to it. I didn't want to get too technical, but I wanted to give a sense really what we wanted to offer as part of this relationship. Really, I'm looking at you two guys, this is the key part. Now, I don't have much time. I think I have less than 15 minutes, so we'll see what happens. So what is personalization at Yahoo? So it's really three things. So understand what makes each user different. That's key. That's personalization. Represent these differences, a critical part. How do we write this down? How do we send it through the company? And then how do we get this into the product? So as Ron mentioned, I play a strong partner to the rest of the company in products. And really, this is one of the most important pieces of the thing. If you can do the first two, but you can't do the third, no one knows. So it's a critical part. So where do you see it? That's another interesting thing that we touched on a little bit earlier. So you see it on Yahoo properties. So this happens to be the front page of Yahoo. You see it on portals. So we have a video portal. So the types of videos you see, we do video recommendation. You see it on Tumblr, right? So now Tumblr and us are together. So even today, we're doing blog recommendation on Tumblr. You see it in mobile apps. So we purchased a company recently you may not have heard about called Aviate. They essentially they build personalized launchers, as we might call them, that organize your apps in a certain way. And we have other mobile applications. This happens to be a mobile version of kind of the video portal that Yahoo has, which they call Screen. And so there we do, again, video recommendation. So what you see is there's many places that this goes, and there's many types of objects and many contexts in which we have to do personalization. So again, doing those first three things is critical. We have to do the first two, what makes you different, how to represent that, and then how do we distribute that to all these products is tricky. So this is an interesting slide. So I kind of cooked this together maybe about 8 months ago to get a sense of what is the scale at Yahoo, and how does that compare to all the other, let's call them personalization companies in the world. It's kind of interesting, back of the hand, scratchy, so don't get too upset if it's a little bit off. But at Yahoo, we easily have 1 billion users, so that's interesting. We have hundreds of billions of page views per month, easily. That's just page views. We got lots of other things that are going on. This is not even including mobile, for example. We have billions of items to recommend, which is quite interesting. So we have lots and lots of articles. We have many, many videos. We have lots and lots of photos, as we just said. We have answers, as Ron mentioned. We got updates. We got Tumblr updates. We got lots of things. Actually, we're getting millions of new things every single day, which is incredible, actually. So if we compare that to some other things I pulled out, Netflix has 30 million people. Not that many, quite less. They have less than 200,000 things they're going to recommend, and they only get 100 new every day. It doesn't seem to be at the quite scale of what we're dealing with. That was interesting to me when I started digging into these numbers. Pandora has 20 to 80 million listeners. There's about 200,000 songs, hundreds new. Similar. The scale is quite different. If you look at Amazon, even Amazon's interesting. It has 200 million accounts. There's 50 million things, and you get thousands new every day. Again, this is back of the hand scratch. I think these are reasonably close, maybe not perfect. And it's not till you get to YouTube that you get someone who's in the same scale. So YouTube, I definitely got billions of users. I got tens of billions of things going on, and I'm getting at least 500,000 new every single day. Some are a second, some are an hour. So you have to really, there's not many people to compare the scale of Yahoo to, which is interesting. I think the main thing why this is interesting is that if you want to do personalization and you have 30 million users, that's quite different than if you have 1 billion. Everything changes in terms of how you represent the people, but how you deliver that to the product, like how you store this information, how do you push it to the product, becomes infinitely more difficult. So challenges due to scale. So what does it mean? Why is having 1 billion items tricky? So one of the tricky things is extracting the same type of signal from all the different types of content items I have. So extracting entities from images is very tricky and very different than extracting entities from, say, news articles, for example. And likewise with tweets. So automatically predicting quality. So predicting the quality of a tweet is very different than predicting the quality of an article or a video. Very tricky, but you have to do all this at the same time. Otherwise, you can't recommend all these things together. Deduping, say, images and news articles are very different. Blending all these things together becomes very tricky. So it just becomes having lots and lots and lots of these types and having billions of them becomes very tricky. Billions of users, the biggest thing I think is space optimization. How do I store 1 billion things about you and then push it around to all these different products? Very, very expensive. Actually, this is one of the most expensive things that we do in Yahoo is actually store what we know about users and actually make it available real time to all the different products. It's a very expensive proposition. I often fight with the engineers because I want to add 1,000 more things that I know about you, and they say, no, you get 10. So it becomes very tricky. Which 10 do I choose? So another interesting point, which may make some sense or not, is that when you have 1 billion users, you have hundreds of millions in different states. So you have hundreds of millions every day of new users. Because people, say, clear their cookies, or they come with a different device, or people are buying new devices all the time, they might come to Yahoo, they might not log in, and they're brand new, and I still want to personalize their experience within a few, say, clicks or taps. So I have to deal with those people every day, plus the people who've been logging in for years, plus the people who've just logged in for a month. And coming up with strategies to solve for 100 million users at a time becomes also very tricky. It's almost like a separate company in each case. Modeling issues, one interesting thing we talked about was last year we said, well, how do you build a billion by billion collaborative filtering matrix? It becomes insane. Even if you could build it, like how do you deploy it? How do you move it around? It just becomes very tricky. And again, many of these problems no one else has to deal with because they don't have 1 billion by billion users. Right? So this last point I think Tom very much appreciates is while at the same time I'm getting billions and billions of new ratings every day between all these billion objects. So it's not that I just built this thing once. I have to update it every second, essentially. This becomes tricky. And so this is really the last thing, which is you start building a good product, and then Marissa comes and says, hey, I want that updated like every second now. So literally everything has to be online. Everything has to be incremental. You can't do anything batch. And you have to do essentially everything very, very quickly. So again, it's another constraint that makes the problem harder and also limits kind of the technology we have today, how it can be useful. So literally all these things have massive research projects that literally we don't know how to solve all these things in the best way today. We don't have enough people, we don't have enough time to go figure this all out. So this is a critical piece, literally, I believe, of the relationship. Again, kind of getting to what is at Yahoo. So we have kind of a high-level architecture where one thing we do is understand content, all the types of content. We understand the users we have, and there's various segments of users. So I talked about new ones, old ones. And then we have a ranking and serving component, you can call it that, which is kind of the recommendation engine itself. This is, and there's, the users are pushing data to all these systems, and we're pushing data to them in some way. And this is very high level in the sense that there may be several of these depending on how you want to push the stuff to users. But in general, you're solving these 3 major pieces. Looking at Yahoo up to today, we have a long history of personalization. We focus on, people tell us things, so we have explicit personalization. In Yahoo, you've been telling us stuff for a long time. We learn things about you, so we implicitly do this. And then we push this to content and ads, and we've been doing this for many, many years. About, more than 10 years ago, we literally invented behavior targeting for advertising, and it was many, many years before anyone else essentially caught up. So it's a very long history. But in the past 18 months, we've had a big focus on that, particularly because Marissa is big on personalization. So one of the things that done is in 18 months, we've literally rebuilt the system 4 times. And so you build the system once, you put technology into it, and you push it forward, and you learn what you need next. And so you just throw the old system away, and you rebuild all over again, right? So rebuilding 4 times in 18 months is kind of a little bit crazy, and actually Marissa's a little bit crazy. So this is great. We fit well together. So sure, we use some stuff from pieces of them, but literally we rebuild each time. And each time you do that, you allow scale in another dimension. So it could be number and types of items or different types of profiles or other types of things. Learning type and speed is a critical one. So we want to be able to learn about you literally real time. You tell us something, we learn right then and give you something better than we would have a minute before. And essentially this is the conversation. So the CMU Partnership, I just wrote a couple bullet points, not critical, but literally personalized experiences, mobile apps. People are looking for information and they're trying to get things done. And what we want to do is enable this new researcher by leveraging the stuff we built. So makes no sense for CMU to try to build 4 architectures in 18 months. We can do that, and we can leverage that and do fantastic research. So I think that's a critical piece. That's kind of the high-level overview. I don't really want to go too much because I didn't have much time, but I had a couple more slides that maybe I'll pass. And at this point, I'll bring up Justine. Thank you, guys.
Thank you, Scott. I know that every time I hear one of these talks from somebody at the research labs, I get more and more excited and more convinced about the similarity in approach, the overlap in interests, and the wonderful enthusiasm that both sides of this partnership bring, and that's very exciting. It's always nice to have people throw money at us, but I'd really actually rather something where we share passion, and that's clearly the case here, and that's very exciting. So we've been talking about personalization, and that's a key word for Yahoo right now. Personalization is also a key word for lots of other people in lots of other places. And it's interesting to me what is meant by personalization. In many places that don't take this as seriously as Yahoo does, personalization is either trivial or it's impossible. So what's actually meant by personalization? What I'm going to do in the next 15 minutes is talk about places where our work is leading to approaches that we're going to bring in this partnership with Yahoo. Beverly Harrison, one of the scientists at Yahoo, has been doing some research into what adults and teens think about personalization. They don't really believe that personalization is going on, and they don't really understand how it would go on. And maybe that's not surprising if this is the kind of personalization we see. So if I take what Scott talked about, really I want to drill down into what's meant by learn and what's meant by understand. And this is how we're thinking about things. In order to really personalize in an interesting way, you need to learn about the world in such a way that you can present that learning to the user. You need to learn about the user, but that's not enough. You can't just stick sensors into something and say, wow, I got all this stuff. You have to use that stuff to make inferences about the user, infer underlying psychological states, for example, or beliefs. And on the basis of those inferences, you can't just stop there. That has to be turned into, and I think that's Scott's product, send it out to product. You have to make that into a compelling experience. It's not enough to say to the user, you are sad. Next user. That has to be turned into something interesting. And those compelling experiences can't be stuck on a desktop or a single device. They have to be available anywhere, anytime, so that that personalization feels like one thing across your experience with Yahoo. So I've just curated some work. Tom and I cherry-picked some work across the School of Computer Science, and there are lots of other examples, but these are some examples that we would like to bring to the table, that we'd like to start out with when we work with you guys. So Tom has been working for several years now on Nell, the never-ending language learner. And Nell has been working for 4 years on reading the web. And it has learned more than 70 million beliefs. Now, what does that mean? That means something like what you see up here. The Maple Leafs play hockey. You might know that. You might not know who the Maple Leafs are. I didn't. But if it's something you care about, you don't want to have to sit your recommender down and say, Maple Leafs, a team, a hockey team. Hockey teams play hockey. I want to know more about hockey. We don't have time for that stuff. So learning about the world in order to present that work to you is very important. Nell has recently been joined by Neil, who is the never-ending image learner. And Neil, like Nell, is running 24 hours a day, 7 days a week, since roughly July, on a 200-core cluster. So this is work by Abhinav Gupta. You can see that in this work also, Neil is learning to extract information about the world, not just from text, but from images. And as you heard from Ron, this is a much more difficult problem. But Neil has already, for example, learned that wheels are round and cars have wheels. And those are the kinds of things that are going to help us recommend interesting stories to somebody, stories that are related to previous stories. But as I said, it's not enough to just gain facts. You have to make inferences about those facts. And in the same way that we need to make inferences about facts about the user, we need to make inferences about facts about the world. This is work by William Cohen, where he's learned how to do inferences across huge knowledge spaces, such as Nell. So really reasoning at scale over millions and millions of beliefs by using random walks across that knowledge graph. So for example, if you want to know what state Pittsburgh is in, one of the things that this system has learned is to look for another city that also might be in Pennsylvania, and thereby figure out that Pittsburgh is in Pennsylvania. Or to look for a company that might be in Pittsburgh. And with some confidence, probably less than the confidence of finding another city, thereby infer that that company is in Pittsburgh and that Pittsburgh is in Pennsylvania, or in Tokyo with hopefully less confidence. So I talked about learning about the world, but it's also important to learn about the user. And Scott and Ron both, I think, talked about news as being one important place where we have to understand what users want to read. One of the reporters who was at the press conference this morning came up to me and said, basically, this sounds really boring. I mean, it's only going to tell me what I'm interested in. This means my life is going to be very dull. And Emma Brunskill is working at forming models of the user that can allow us to find stories that appeal to the user already, but in places where there are uncertainty in the learned model, we can present news stories that allow us to understand whether something new is also interesting to the user. So this is one way of understanding the user, making inferences about the user. Another way of gathering data about the user is what Aninde calls behavioral imaging. So our mobile devices have lots and lots of sensors on them today. There's a GPS, there's Bluetooth, there's a battery, there's Wi-Fi, often an accelerometer, a barometer, a magnetometer, all kinds of things, all of which can collect information about us in much the same way as an X-ray might have done imaging of a human in the past. But as I said, it's not enough to simply collect those facts about a user. What can you do with them? And Aninde has developed the AWARE framework. And this AWARE framework allows him to do truly exciting and important inferences from that behavioral imaging. For example, he's built GPS systems that can predict where you're going and therefore proactively route you around traffic, rather than my current GPS, which I have to keep pressing find alternate route until it randomly finds one that works. Reminder systems that can notice that there are anomalies in a schedule and routine events in a schedule, and use both of those to predict the best way to deal both with your routine and with the anomalies, and so forth. It can detect multiple types of engagement. It can detect predictors of binge drinking. It can detect various symptoms of disease. So one of these systems uses behavioral imaging to predict which children are going to be diagnosed with autism. Autism diagnoses happen relatively late in a child's life, usually when a child goes to school, but by that time it's very late to do an intervention. If you can predict from behavioral imaging who's going to be diagnosed with autism, you can intervene much earlier and much more effectively. Another way of gathering data and inferring underlying psychological states is in this work by Jason Hong and John Zimmerman. So we know that returning soldiers have a high rate of depression and a higher incidence of PTSD than the general population. And they carry cell phones, and cell phones, of course, monitor not just the numbers that we call, but the patterns amongst those numbers. They also know where we are, and they know that when we're moving. And we can also, with many devices, for example, this one that I'm wearing, detect sleep patterns. So Jason and John have been able to show in preliminary results that they can detect the likelihood of depression and PTSD based on amount of time spent at home. So you can imagine that somebody might go from home to the supermarket to visit a friend and to work. If they stay at home all the time, or if they simply go from home to work with no other social contact, you might imagine that something is wrong. So a combination of time at home, disrupted sleep, communication volume is correlated with self-report on the CESD scale. And that's very important work in today's world. Work by Dan Swarek similarly uses behavioral sensing, in this instance, to do something that seems quite out in the future, which is to detect the emotion that the user of a system is feeling. So this is a coach that helps people who've had strokes to regain the use of their limbs. But one thing that we know about stroke victims is quite often they may not have the same amount of language as they did earlier. How do we know how far to push them? And if they're working with an autonomous system without a therapist in the room, how do we know when we've gone past what's helpful to them? Well, this particular system does emotion recognition, infers emotions on the basis of behaviors on the part of the user, and therefore knows when to stop the coach and say, would you like to start again another day? Once again, it's sensing aspects of the user and using those surface level behaviors to make inferences about things that we cannot see, that is, underlying psychological states. But of course, it's those psychological states that we want to act upon, and so those inferences are key. I talked about the work on anomalies and routines, and Jason and John did the initial work on the sensing. John and Anind worked on turning that into a compelling experience. This is a system called Person, Place, Time View. And if I'm correct, this may have arisen from a time when one of the parents doing this research left a child standing on a curb because it was assumed that another parent was doing the pickup. Well, it happens to all of us. Our maybe not that exact thing, but the fear of that, certainly, because our routines are so complicated and because we're trying to reconcile them with the very complicated schedule of somebody else. So this system learns and displays plans that are often undocumented in the family routine. And something like that can reduce your anxiety around leaving a kid on a curb, allows you to plan a better life, and as such also allows people to feel like they are being taken care of in the way they want to be taken care of. So it's not that the system does something for you, it doesn't pick up your kid for you. It allows you to feel like a good parent in picking up your child. An interesting twist on what I've been talking about in terms of sensing things about the user, inferring underlying states, and providing compelling experiences is work being done by Jeff Bigham with a team of others. And what's interesting about this is that rather than building an autonomous agent or assistant to help people with answers to particular tasks, he's built a system that can gather together answers from the crowd in such a way that those answers can be transferred to the user in real time. So you can ask a question like, I'm on vacation in LA, I was hoping to find a good place for lunch tomorrow, and virtually instantly you can hear back, what part of LA are you in, westward over by UCLA, I'd try pizzicato, and so on and so forth. This looks like a real conversation because it is a real conversation. However, what you need to know is that there are hundreds of people looking at this question, submitting answers, and the system is choosing the best answers and bringing those together to make something that looks like a single assistant giving you aid. What's just as exciting as that, however, is the fact that these data are then sent back to us to use to train natural language processing systems, to train personalization systems so we understand, for example, the kinds of questions that are asked so that we can be ready for them, the kinds of answers that we need to provide, and how information needs to be gathered in order to provide those answers. So this is a kind of a loop that brings us to better AI by initially using a crowd. Finally, I said that these compelling experiences need to be available anywhere and everywhere. They need to segue from our desktop to a variety of mobile devices or tablets to the dashboard of our car. And that's going to be what allows us to feel like we truly have information at our disposal rather than devices at our disposal. We have the knowledge that we need. Other kinds of compelling experiences aren't just on mobile devices, but are on our own bodies. And work by Chris Harrison has shown that we can bring users closer and closer to the computing power of these personalization technologies by actually displaying information on the user's own body or on the world around the user. And new work by Chris is, in fact, developing a light bulb. In this instantiation, the light bulb had wires, but in the most recent instantiation, this is work he's doing with Robert Zhao, this light bulb is wireless. It just screws into a socket and turns whatever is beneath it into an interactive computing surface. So everywhere, persistent, available, personalized, with a much more deep version of personalization. These are the things that we're really excited about pursuing in this collaboration.
So we have time for some Q&A. All and every questions are appropriate here. Yeah, and we'll bring up our speakers here.
Tell you what, there's too much of this Yahoo on one side, CMU on the other side.
Okay.
Here, take one. Okay.
What's that time span for the InMind project? How many years is this going to last?
I don't know if these are on. The agreement is for 5 years, and you may have heard the total funding is about $10 million.
Switch it on the bottom. I don't know if you really.
There you go.
Low?
I think this room works fine.
Yeah.
That was, Yes.
Well, so organizationally, what's the contact point? I'm not sure that was said.
Organizationally, what's the contact point? I don't know.
It's pretty simple. So on our side, we have Don McGillen. Don, why don't you stand up and show yourself? Don is one of our campus relationship managers in our academic relations organization. Don lives here. As Randy said, he's not only an alum, he's a former employee of the university. So he's very local. So he's our main liaison person around anything having to do with the partnership. And then we have on our side a series of technical leads along several tracks that are quite critical. So there are 3 or 4 people who on the Yahoo side have agreed to kind of be the primary contact along lines of machine learning, let's say, or HCI, et cetera. And on your side, go ahead, Tom.
I would say for the faculty who are interested in the question of, well, how do we get engaged in this, or the students, the answer to that is that Justine and I are the co-directors, and that now that the press release is out, in the next few weeks we'll be sending around a memo to all the faculty explaining the structure of the project. But what the key thing you should think of if you're doing research you think might fit into this in an interesting way is that what we want to do is different from the typical NSF funding agency where you apply with a proposal to some interesting idea that might then get funded, and you might go off and do it by yourself, publish a nice paper, and get a Best Paper Award. We're not interested in specifically doing that kind of Lone Ranger research. What we're interested in is using this as an opportunity to pull together the most relevant, most exciting research that could fit into an integrated collection of software that's supported and hosted on this Yahoo infrastructure so that we can really build a living research environment on top of the Yahoo infrastructure. So if you're thinking about how your research could fit in, think about it in those terms, and then come talk with Justine and I.
Maybe you could talk a little about what you anticipate this week. You know, that we're actually going to be deploying this on apps on phones.
So you're also going to see a memo from Tom and I inviting students to opt into this project. And we've been talking about sweetening the deal with some mobile devices. So we'll be inviting people to be one of the users of this new community. What's so exciting about this is, and this has never happened, certainly to my knowledge, we're going to have access to everything on the Yahoo side that will allow our opt-in users to have initially the current Yahoo experience, and then increasingly that experience enhanced with replacement software or brand new software and hardware that we develop. What's fabulous about that for the user is it's exciting. You're part of a really fabulous research project, and you're going to have an increasingly personalized experience. What's exciting about that for us is that we have access to thousands of instances of use of everything we develop, and so we can very quickly iterate and turn around and send back out into that situation improved versions of everything we build.
So you spoke a little bit about some of the strengths that Yahoo brings with infrastructure and being able to do things very quickly. Obviously, CMU has a lot of human capital, and they're able to provide research and thinkers who are going to be contributing to the project. But can you talk a little bit more about the breakdown of what are the responsibilities of Yahoo and what are the responsibilities of CMU for this partnership?
To start with, as Justine just mentioned, we haven't finished building, but we're in the process, this infrastructure that will allow people to build new versions of our current services on top of with their own ideas, or brand new services that we've never considered before. So one of our most critical obligations, sooner rather than later, if we can, is to get that built and get it shipped over here, or at least available to faculty and students here at the university. I think there, in terms of formal obligations, there isn't a lot written sort of in contractual language that says we must do this and you will do this. This is really a joint, large-scale research effort. So a lot of it's unpredictable. I guess our commitment on both sides is to engage significantly with each other and tackle really interesting problems, bring our best people to bear. So for our part, we have great scientists around the world. It's just like Tom said earlier, sort of a call for people who, and Justine sort of made it very clear in her sort of portfolio of work that she presented. We are looking for, and have already looked for, people whose work and interest are very well aligned with this kind of collaboration. And we will be encouraging people to come to Pittsburgh as necessary, offer internships to students for the summer to come work with them, and be part of a larger effort together. But it's not like a contract to execute a certain system development task together with milestones. It's truly an open-ended research project with kind of a shared long-term vision and a lot of excitement about the technology and science that it would take to move things forward, and then we'll see where it goes. We have, the obvious things like planned regular meetings. As I mentioned earlier, it's not like a DARPA contract, go, no-goes or anything like that. So we'll take it one step at a time. In 6 months, we'll evaluate where we are. We'll change direction if necessary, same thing in a year. But I think the most important thing, as we've emphasized a few times, is the commitment to sort of this long-term, very substantial funding model that gets out of the way the need to kind of constantly go back and report on what you're doing, or ask for more money, or worry about whether your students will be supported next year or in the third year of their graduate program. So that's clearly taken care of. That is contractually spelled out. Any other thoughts, Tom?
If I could just maybe add two concrete examples of things. So one concrete illustration of how we might interact is based on Emma Brunskill's work. I don't know if Emma's there she is. So I'm not trying to put you on the spot, Emma. But Emma does, as Justine pointed out in her talk, some really interesting work on bandit problems, exploitation, exploration in active learning of user preferences. And one of the early, I won't say first because I'm not trying to put Emma on the spot, but one of the earlier things that we hope to see is Emma's research extended and tested out in an app like Yahoo News, for example. And so that would be a kind of very concrete example of the kind of work that we'd like to do. But that, when I give that example, that's one faculty project with her students working on this. You can see the direct relevance. But more broadly, the second example I'd point out is if you think about what Justine just presented as a collection of research and the 5 themes that she brought up at the beginning of that, you can see that a key part of what we want to do here is build models of the user, both of their preferences and their long-term state and demographics and so forth, but also of their instantaneous state. Tom is currently sitting here speaking. It wouldn't be a good time to ring the cell phone. So another second example would be we'd like to pull together the many different research projects that are currently going on and integrate those into a system that builds a single model and takes advantage of Anin's work and of many other people's work so that instead of having 5 different research projects looking at different aspects of user modeling, here we really have an opportunity to integrate those so that each of those research projects can leverage off the other features of the user that the other projects are learning. So that I wanted to bring up those 2 examples just to try to ground it out and to point out what really is the key opportunity here. It's synergy is the key opportunity.
Yes. So is there room for some eat your own dog food type of approach, saying that if I want to try out something that I've been running on my desktop computer and I would like to use it, but I can't wire all my funds and do things, would that be something that could fit into this framework?
Yeah, I think that's saying in different words exactly what people were implying before that. I think the success of part of this will depend on the number of people on campus here who opt in to participate in this potentially broad-scale living laboratory. In some of our earlier DARPA projects, we had the same thing, and with enough users who have agreed, you know, my data in this experimental setting is okay to use, everybody benefits. But in fact, that's very much the idea here, is that largely from Carnegie Mellon, there will be experimentation with extensions or novel services that can be built on top of our infrastructure using current and who knows what future mobile devices. And the whole idea is to try it in the real world and see what happens and learn through user experience what is pleasant and usable and what is distasteful or non-useful, and make adjustments in real time. And I think, again, one of the most exciting things about this for us, and I hope for our partners, is the fact that we're going to try to get everyone access to the real stuff. So instead of in a classroom setting, you get 6 students over a semester creating their own mini version of Yahoo Fantasy Football or whatever, which can happen, but you don't get the real thing. You get to use the real thing. And so you don't have to rebuild it. You can move on to the more experimental, interesting stuff and collect data from your own community and start to understand what the use is like. So in some regards, a major emphasis of this is, I hate this term, but I'll use it, dog fooding. We use it at Yahoo now all the time. I don't know whatever happened to beta testing, but in any case, indeed, I think that's a major part of this enterprise, and hopefully it'll provide a great venue for doing really interesting research.
So we have time for one last question.
Just a couple of points. One is that there are processes in place for young scientists to suggest projects and collaboratively define projects. And then the other thing is just to maybe Tom, a little more on the structure of what a project is, you know, what the funding will be used for, including faculty summer salary, all designed to really promote the collaboration, active collaboration.
Right. So just to elaborate one point on Don's suggestion, what is a typical funding unit, for example? And what we're thinking is that, remember, this is a gift from Yahoo, not typical university overheaded research fund. So we're thinking on the order of $100,000 for a one-year unit of funding to support a PhD student and a substantial fraction of a faculty. And you know the numbers for, so if you multiply that by the usual overhead rate, that's like 170K or 160K NSF grant. But in there, the support for that student makes that student a Yahoo fellow. And we're hoping that through awards of many of these, we'll have a whole community of Yahoo fellows who, and we'll encourage both faculty and the students to take a trip out to Yahoo sometime during that year and really explain the research they're doing, get to know the research going on there.
So, time for one more question, I think. Yes.
Question about multilinguality. Is the resources for English, or is there a commitment to working in other languages?
I think in our discussions leading up to finalizing the basic agreement, we didn't get specific about that. Yahoo, of course, is present in a very large number of countries, and not everything we do is in English. In the labs, we don't have a lot of work going on right now around multilingual processes, applications, et cetera. I think it would be important for the company. We haven't given it much thought, I guess, specifically in terms of what we would do. So if you have some ideas, I think the best thing is to propose them and figure out how it might fit, and then we could see how things fit in. But we are an extremely international company. And so, at least on the face of it, that consideration is really quite important, certainly to us at Yahoo.